Okay, today in pre-cal we learned about parabolas. This is the last unit in our section on conics. And you've talked about parabolas before when you did quadratic functions all the way back starting in Algebra 1. On these parabolas we're just going into a little more detail. The first thing is the directrix. And that is a fixed line. The set of all points. That are equidistant. And equidistant means equally far in distance from a fixed line. And then we have the focus, which you've been calling the foci in the previous lesson because there were multiple, and for a parabola there's only one, and that's a fixed point. Kind of the same concept as the directrix, but in the opposite direction. And we're talking about what that is. If we look at a parabola, if it was drawn perfectly, which this one probably won't be, if I draw this perfectly and put the focus here contained within the parabola and the directrix equidistant apart, the same distance away as the foci or the focus, then I could draw a point to my parabola here and take that same point and connect it to my directrix, and these two lines would be the same length. The reason that we do that for one example is like a satellite dish. If it bounced in the signal and stopped here, it would bounce back to here to the receiver, and that's what allows you to watch cable television. So that's one thing that's used for. Let's talk about what you really need to know to be able to do your homework. The vertex is the same that it's been all week, and that is HK. There are two different cases. One is where the parabola opens up and down. That's kind of the type you've been doing for a long time. And then there's if it opens left or right. And that is an or, not an and. Yesterday when we did hyperbolas, it was both ways. Today it's just one or the other. The two equations that work for these are y minus k equals 1 over 4c times x minus h squared. And these are kind of the parent functions. The hk gives you the vertex. The c gives you your foci and your directrix. And for left and right, you have x minus h equals 1 over 4c times y minus k squared. And let's look at two different examples. Example number 1 is to determine the vertex, axis of symmetry, focus, and directrix of the following. So basically find all the information and then sketch it. The equation is x squared equals 12y. And when we look at that, to be able to tell whether it opens up, down, left, or right, the first thing we want to see is where the squared is. Since in this one the squared is located with the x, it is the most like the up and down, because here the squared is with the x. So we know it's either up or down. We can tell by the fact that we have all positives here that that's going to be up and not down. Down would be negative, also left would be negative in the other case. We want to get it to where it looks more like the parent function, so we want the y to be by itself. So we're going to divide both sides by 12. And if I rewrite this, my new equation is y equals 1/12 x squared. Notice I'm pulling this out in front so it looks like this 1 over 4c. The next thing I want to do is to solve for c. So 1 over 4c, I'm pulling that straight from the equation, equals 1 over 12. And if you set the bottoms equal to each other, it should be easy for you to see that c equals 3. Let me point out here that on the homework, sometimes you're actually going to have to set 4c equal to 12 and divide both sides by 4 to get your answer, because it may not be as easily visible what that answer is automatically. Decimals and fractions are fine on the homework if you come up with one like that, and you should starting on number 14. So that's your c. Now we can use the equation in the c to find all of our information in graph. So starting with the vertex, we are looking for an h and k. Those would be in parentheses with the x or the y. Since there are no parentheses in this problem, the vertex is just 0, 0. Sorry, my phone's ringing. Okay, now we need to find the axis of symmetry. We know that the symmetry is going to be an x equals line because the squared is with the x, and because we're opening up and down, we want the line up and down that makes the parabola symmetrical. And we take x equals and look at what that x term is. So in this case, that is 0. X equals 0. We need to find our focus. Since the axis of symmetry dealt with the x, the focus, and the directrix deal with the y, so we're going to do 0 from here, and then the focus is 3 away from 0, which is just 3. And the directrix is 3 in the other direction, so that would be a -3, but it's not a point, it's a line. If this one was x equals, the directrix is y equals, and so y equals -3. That's all the information we need, and now we need to sketch this. So we're going to go a couple marks each way. Start by putting your vertex at 0, 0, put in your focus at 0, 3, and your directrix at -3. And then because we have the 1/12, we know the graph is wider than normal, so we're going to draw a pretty wide graph here. And I'm not being real exact about that, but just kind of a sketch is fine. So that would be one like opens up or down. Let's do a quick example of what would happen if we want to open left or right. Example 2, y minus 3 in parentheses squared equals 8 times x minus 2. You should be noticing that the squared is with the y, so this is going to be a right or left. Let's work towards getting the x term by itself so we can get our c, and so we can see if it's positive or negative. So divide both sides by 8. And so we have x minus 2, I'm just rearranging here, equals 1/8 times y minus 3 squared. And this is positive right here, so it's going to open to the right. The 1/8 is going to help me find my c, so 1/8 equals 1/4c, and c is equal to 2. If I look here at my vertex, my HK is 2, 3. Remember in the original formula it starts out negative, so if there's a negative sign that does kind of flip to give you your vertex. My axis of symmetry, because the squared is with the y, it is a y equals line, and y equals here is 3. My focus, then we'll deal with my x. So if I look at my x, this is a little bit different since the center is not at the origin, or the vertex is not at the origin. My c was 2, so I want to go 2 more than the vertex, which 2 plus 2 would be 4, and my vertex, or my focus, excuse me, is at 4, 3. And then my directrix is 2 in the other direction, so we have x equals, and 2 minus 2 would be 0. And that's all my information that I need to be able to graph this, so sketch a graph. 2, 3 is my vertex. My axis of symmetry is here at 3. My focus is at 4, 3. My directrix is at x equals 0. And again, we have 1/8, so this is a fairly wide graph. Don't forget that the focus should be inside of your parabola for it to be correct. The assignment is A10, and that is page 740. Numbers 5 to 10, which are matching, and 14 to 18, which are like the examples we just did in our notes. Good luck. Let me know if you have